Chapter 4, Lesson 1, Part 2, Using Models to Write Ratios. Again, remember, with ratios, order is very, very important. And whether you're given a picture or a bar model, we should be able to write ratios as long as we're talking about the same type of unit. So if we can only compare two measurements of length or two measurements of weight, we could not compare length to weight. All right, so we have an example here where they show that there are 31 U.S. stamps and 24 foreign stamps in a collection. Find the ratio of U.S. stamps to the number of foreign stamps. So a bar model was just drawn here to show 31 stamps, U.S. stamps, and 24 foreign. Okay, so it says the ratio of the number of U.S. stamps to the number of foreign stamps is 31 to 24. Again, we put 31 first because they asked for U.S. stamps first. Then in Part B, they say find the ratio of the number of U.S. stamps to the total number of stamps. So first, we already know the number of U.S. stamps. We know it's 31, so we can start there. But to find the total number of stamps, you can just add our two numbers together. No big deal. 31 plus 24 is 55. So in this case, your total of 55 wasn't originally shown, but you had to do an addition problem to answer it. All right, so number 9, it says of 100 people at the concert, 67 are adults and the rest are children. So first we need to find the ratio of the total number of people to the number of adults. So the total number of people, they told us right here is 100. And then they said to the number of adults, again, information they already gave us. So the ratio to the total number of people to the total number of adults is 100 to 67. This is Part B that got cut off. They want us to find the ratio of the number of adults to the number of children. Again, we're going to have to do some math here to figure out how many children there are. We know there's 100 people total. And then it says 67 are adults and the rest are children. So all we're doing is simple subtraction. 100 minus 67 is 33. So we have 33 children. So the ratio of the number of adults to children, again, we're starting with adults, is 67 to 33. And then the ratio of children, this may have been Part C if it got cut off, I'm not sure. The ratio of the number of children, again, we found out we have 33 children. So I write that first. To the total number of the people is 33 to 100. So again, remember that order matters. You might have to do some addition or subtraction to figure out a missing piece of information. All right, so let's do number 10 together. We have an example where we're talking about some casseroles. Adam made 19 chicken casseroles and 36 tuna casseroles. So right away, I'm just going to draw a little bar here to represent this. So we have chicken here, and that's 19, and then we have tuna, and that's 36. And this would represent the total. I don't know what that is at this time. Part A asks you to find the ratio of the number of chicken casseroles to the number of tuna casseroles. So I write the number of chicken casseroles, which is 19, to the number of tuna casseroles, which is 36. In Part B, it says find the ratio of the number of chicken casseroles to the total number of casseroles. Well, I already know that there's 19 chickens, so I can write that. But for the total number, of course, you're going to have to add to find out. So 19 plus 36 is, of course, 55. So 19 to 55 is the ratio of chicken casseroles to tuna casseroles. Why don't you try number 11 on your own here? Try answering both A and B. Take a pause, read it, try and solve it, and come back and check your answers against mine. So for part A, your answer, because they're asking the total number of athletes, that should go first. 120 to 71. We're just using the information they gave us. And find the ratio of the number of tennis players to the number of swimmers. So we don't know tennis players. We're going to have to take the total and subtract the number of swimmers. So number of tennis players is 49. That goes first because they asked for tennis players first. To the number of swimmers, 71. Okay, so bar models that are partitioned or broken up can also be used for ratios. Instead of having one long bar, we have it broken up into two sections. So in this example, we have the ratio of the number of girls to the number of boys in a movie is 5 to 4. So we have girls represented here with 5 boxes of equal size lined up to make one long bar, and then boys 4 boxes of the same size lined up together. So part A says, what fraction of the children at the movies are girls? Okay, so when doing fractions, you're first going to find for the numerator is going to be the population they're asking you about. So in this case, it's going to be girls over the denominator, which in this case, they're asking about what fraction of all the children. So in this case would be all children. So we're writing it in fraction form versus ratio form. So in this case, we have 5 girls over 9 children total, which they just did by adding 5 plus 4. It's no different than saying 5 to 9. This is just 5/9 of the children are girls. It's still a ratio. So in part B, what fraction of the children at the movie are boys? So again, we know the total number of children is still 9. This time our numerator is 4 because there were 4 boys. All right, so let's look at number 12. The ratio of the number of red highlighters to the number of blue highlighters is 2 to 3. They already drew our boxes for us. So what fraction of the highlighters are red? So when they say of the highlighters and don't break it up, remember they're talking about the total. So to find the total, we're just going to add the total number of red, which is 2, to the total number of blue, which is 3. And of course, 2 plus 3 is 5. So because they're asking about the red ones, our fraction should be red over total, which in this case is 2/5. And then what fraction of the highlighters are blue would be what's left over, 3/5. All right, so number 13, a bracelet has 12 orange beads. So I'm going to start by just drawing 12 boxes to represent my orange beads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's orange. This is the closest color I have to orange. And 11 white beads. So we'll use the black outline, but they'll represent the white one. 1, 2, 3, 4, 5, 6, 7. So those are the white beads. So right away, I'm going to recommend finding how many total beads there are. And you have 12 plus 7, which of course is 19. That'll help us answering. So 13A says find the ratio of the number of orange beads to the number of white beads. So the first one saying number of orange to white. Well, we have 12 to 7 because there's 12 orange beads to 7 white beads. Now, part B says what fraction of the beads are white. So our fraction is going to be the number of white beads over the total because it says what fractions of all the beads. So we know we have 7 white beads and there are 19 beads total. So the answer, the fraction of the number of white beads are 7/19. All right, so I'd like you to give number 14 a shot. I'll help you out with just drawing this bar model over here. There are science books and math books on a shelf. The ratio of the number of science books to math books is 4 to 9. So that means I have 1, 2, 3, 4 science books. Again, I know there's 4 science books because they said science first and then said 4 was first. And then for math, we have, shouldn't connect there, 1, 2, 3, 4, 5, 6, 7, 8, 9 science books. So first off, it says find the ratio of the number of math books to the total number of books. So again, we know there's 9 math books. You can write that first. But to find the total, you should be adding 4 plus 9, and you get 13. So that's the other half of your ratio. And then what fraction of all the books are science books? So you'd have science over the total to answer that. And we know we have 4 science books out of a total of 13. So the fraction answer is 4/13. And the last part of this lesson is talking about using ratios for calculations. A lot of times when working with ratios or comparing two things, they'll say how many times as large or how many more of a certain thing. So we can actually use that ratio to do the calculation to figure it out. So we have this example here where it says the area of a square A is 36 square inches and the area of square B is 9 inches. So they want to know how many times the area of square B is the area of square A. So that's where we set it up as a fraction. We put square A on top, which they did there. I don't need to rewrite it, over square B. And then they had the fraction of 36 over 9, and they simplified, which wound up just being 4. So square A is 4 times the area of square B. Again, the order of the wording is very important. How many times the area of square B is the area of square A. When they word it like that, square B is on the bottom and square A is on the top. So in part B, they flip it. How many times the area of square A is the area of square B. So square A is on the bottom because they say it first, and square B is on the top. So now we have 9 over 36. And again, they just simplified here. They divided by 9 to get the greatest common factor and got 1/4. So the area of square B is 1/4 times the area of square A. All right, so let's get number 15 and 16 done. Kelvin saves $60 a day. Al saves $90 a day. How many times Kelvin's savings are Alan's savings? So because they ask about Kelvin first, he's going on the bottom of this fraction, and Al will be on the top. So Al earns 90. Kelvin earns 60. So then we just want to simplify by dividing by the greatest common factor. In this case would be 30. And 90 divided by 30 is 3. And 60 divided by 30 is 2. So Al's savings are 3/2 of what Kevin saves. So the other way around, we want to know how many times Al's savings are Kelvin's. So Al would be the denominator, Kelvin would be the numerator. So it would just switch again and be 60 over 90. We'd still divide by 30 because it's the greatest common factor. And this time it would be 2/3. So we would say Kelvin's savings are 2/3 of Al's savings. And number 16, Joseph uses 30 grams of sugar and 24 grams of butter for making pancakes. How many times the amount of sugar? So they're asking sugar first, so we're going to put that on the bottom. How many times the amount of sugar is the amount of butter? So that would be 24 over 30. And again, you always want to simplify these. So we would divide by the greatest common factor, in this case, which is 6. And the answer is 4/5. And then in part B, again, we just flip it. So we'd have 30 over 24. And we're still using the same greatest common factor, which is 6. So the answer here would just be the reciprocal as well. And that's it for all of lesson 1 of chapter 4.